good morning, good afternoon. Right, so today on this lesson I'm going to explain how to solve equations with matrices, how to solve linear equations using the matrices. Before I start with this, let's just go back a little bit just to remind you of how to find the inverse of a 2 by 2 matrix, which we just covered last lesson. So as you can see, if we have a matrix, if we have the matrix A equals A, B, C, D, okay, to find the inverse for it, there is an expression as A inverse equals 1 over determinant A, multiply by adjoint of A, adjoint A. Okay, so the adjoint, basically what you do, you need to change these value, the A and the D, not change, sorry, swap them over, and this is going to be D and this will be A, and B and C, you change their signs, so this is going to be minus B and minus C. Okay, so how to find the determinant? So that determinant A, or you can write it this way, the determinant is basically from the original one. From here it's A times D, so it's A D minus B times C. So this is the determinant, okay? Determinant of A. Determinant, okay? The adjoint, let's do the other one. The adjoint A, adjoint A is, as we said, it's like you swap over these two values. So you swap over the D and the A, and you change the sign for these yellow one, the A, the B and C. Okay, so the adjoint is going to be here D and A, and this going to be minus B. Change the signs on the other column and the other diagonal here. Right. So the A inverse, okay, which is the inverse matrix, is 1 over the determinant multiply by the adjoint. So that's D minus B, and this should be minus C and A. Okay, right. So this is just to remind you of how to find the inverse, and as we're going to need it to solve our equations with matrices. Okay, so finish from this. Okay, let's do the solving equations with matrices. So suppose we have the matrix A, which is the matrix A 2 by 2, and it's a non-singular. That means the determinant A not equal 0, and that means we can invert, it can be inverted. So when we say non-singular means that A not equal 0, and that means it is invertible we can find invertible, we can find the inverse for it. Okay. So by so if there was a matrix, a 2 by 2 matrix, which is non-singular, that means the determinant of A is not equal 0, that means we can find the inverse for it, then where AX, we can use this expression, AX equals B. You can use this expression, AX equals B. All right, where AX, A is the matrix A, and so it's AX equals B. Right, where X here is, A is the matrix, and X is the matrix of the variable, and the B is the matrix of the products, or we can say it's the column of the constants. Okay? Right. Right. So where B and X are both, we need to multiply two matrices. They have to both have the condition as the number of rows of one of them is the same number of the column of the other one. So if A is 2 by 2 and X is 2 by 1, and because these two middle numbers are the same, that means we can multiply them, and the product is going to be these outside, so the numbers of row of A and the numbers of column of X. So the result, the B, is going to be 2 by 1. Okay, so that means basically we can multiply them. If the matrix A was non-singular and multiplied by X, which is the matrix of the variable, which is represent X and Y. Okay, so how can we write this? Basically, we are interested, so when we have AX equals B, we are interested to find X here, because this X here, the matrix X, it represents the values, the variable of X and Y. Okay? So, to find X, we multiply this both sides by A inverse. So A inverse times A times the matrix X equals B times A inverse, or A inverse times B, same. Okay, and because we already know that A inverse times A equals the identity, which is I, therefore we can say this going to be I X equals A inverse B. And also because when you multiply I by anything, by any matrix, you will get the matrix itself. So because I times X equals X, I times X equals X, therefore this means X equals A inverse B. So that's how we get this expression. So that's how we get this expression, which we will use for solving linear equations. Okay? Right. So to solve a linear equations, basically that means finding the values of x and y for them. There are few steps we need to do them, so we will be able to solve the questions. That means find the values of x and y. Right, let's see here. Yeah, so here just saying that we use this form, okay, for solving simultaneous linear equations. Okay, so for example here we have the example 2x plus y equals 9 and x minus 2y equals minus 8. Okay, you can see the example here in the slide. I just put the picture of it here, but I will work it out in aside. Okay, so I'll just write the equation. So it is, let's say it's 2x, standing space, 2x plus y equals 9, 2x plus y equals 9, and the other one is x minus 2y equals minus 8. Okay, so these are two equations and we need to solve it. So first of all, what we need to do, like how to solve it, what we need to do, we write this in a matrix form. So in a matrix form, that means we write a matrix. It has the coefficients of the x and y. So we have this here is 2, and so that's the 2 here, and this is 1y, yeah, this is y, that means it's 1y, so there is 1 here, and there is x here, so that means 1x, so I put it there, and there is minus 2 here, so that's minus 2. Okay, so this is the matrix of the coefficients, which represent the matrix A. Right, and this multiplied by the matrix of the variable, or the matrix X we call it, because it has the variables X and Y. It has X and Y. By the way, this X here, it's not the same as this X. Yeah, it's not the same. They are different. Right. Oops. Because this X here, the big one, it represents the matrix X, which it has the X and the Y variables. Anyway, so this equals, so these multiply together will give us the product, which is the 9 and minus 8. Okay, and to check this is same as, why we call this a matrix form, so matrix form. So basically what we did, we changed the equations here, the two equations, into one single matrix form, How to check it works? This is equal B, this is the B matrix. If we multiply these together, so let's say if we do 2 and 1 times x and y, let's see what we will get. So if we multiply them together, we will get 2 times x, which is 2x, plus 1 times y, so that's plus y, equals 9, yeah? Or let's say this is equal here, and if we multiply the other one, if we multiply the other row here, which is the 1 and minus 2, we will get 1 times x, which is x, and minus 2 times y is minus 2y. So this is minus 2y. And as you can see here, this is the same as the first equation here, and the second one is same as the second equation there, right? So that's why we say this is a matrix form, because we wrote these two equations in one matrix form. Anyway, what we need to know, or what we need to do in solving the question, we need to know the expression of ax equals b, where a is the matrix and x is the matrix of the variables, which means x and y, and this equals b, which is basically the product or the answers of the equations. Yeah, the constant column, which is the values here, and this the matrix A. Okay? Now, how to solve this? So far just we know how to set it, yeah, how to change these two equations into one matrix form, which is this one. Now, how to solve these? That's what we will do now in the example. I'll just do an example and show you how to do that. Well, actually, we have this question here, so let's start. Right. Okay. Now, to solve the equation, basically, so after we reach this, like we have ax equals b, yeah? So we already have ax equals b. Then, as I explained earlier, we multiply both sides by a inverse. So this a inverse times a times x equals a inverse b. And this gonna, because a inverse times a is I, then it's ix. And that's a inverse b. And ix, because the identity matrix, if we multiply it by any other matrix, it will give you the other matrix. It's same. So therefore x equals, we can say x equals minus 1 and b. And that's what we are interested of, which is the matrix x, because this has the variable x and y, right? So from this expression, we can see that we need to find the inverse matrix. Okay, how to find the inverse matrix? From the slides above, or from last lesson, we learn how to find the inverse matrix, and I'm just going to write it down here. So first of all, the A inverse is 1 over determinant A multiplied by adjoint of A, adjoint A. So the adjoint, remember, you swap the values of the diagonal and change the sign of the other. So in our case here, I'll just do them separate here. Yeah, this is the adjoint, basically is the question is the matrix is 2 1 1 minus 2, so the adjoint is going to be minus 2 and 2 here, and these both of them 1, so both of them are going to be minus 1. So this is the adjoint. Okay, right. Now the determinant of A, determinant A equals is from the original matrix here we have, it's 2 times minus 2 minus 1 times 1, and this will give us minus 4 minus 1, yeah, and that's minus 5. Let's keep moving. Okay. And remember the determinant here, it's okay to be negative. It doesn't have to be positive, yeah? It could be positive or negative, it doesn't matter. Right, so we found the determinant here, which is -5. And we need to find the edge joint. So the edge joint of A, if A, like A was, where is it? 2, 1, 1 minus 2. That's the original, yeah? It's 2, 1, then 1 minus 2. Therefore, the edge joint of A equals, what we do, we swap these two diagonal. We swap them, yeah? So the -2 becomes here, and the 2 goes there. And also, we change the sign of these two terms. So this is going to be -1 and -1, because both of them positive. Then we change the sign for them, so it becomes negative, right? Now we find the inverse. So A inverse equals 1 over -5. So that's 1 over the determinant, multiplied by the edge joint, which is -2, -1, -1, and 2. Okay, so this is like -1 over 5 multiplied by each term inside the matrix. And we can just leave it like this, or if you want, you can write it down this way, which is -2 times -1 over 5 is a +2 over 5. So it's 2 over 5. And -1 over 5 times -1 is 1 over 5. And -1 over 5 times -1 again is 1 over 5. And -1 over 5 times 2 is -2 over 5. So this is basically the inverse matrix. We want to find X, the matrix X. So as we said before, X matrix equals A inverse multiplied by B matrix, which has the answers from the equations. So I'll just write X as a matrix, which is X and Y, equals A inverse, which is what we found already. I'm just going to make it easier for us to multiply, so I'll just write it down as -1 over 5 multiplied by -2 -1, -1, 2. And this is going to be multiplied by B, which is, what was B? 9 minus 8. 9 and -8. Okay? So we can put this, the -1 over 5 at the end, don't worry, just to make it easier when we multiply now. So now what we need to do, we will multiply these two matrices, these two together. So basically we'll start with the first column first row from here with this column basically. We only have this one, and then the second row with this column again. Okay, so let's start. So this is going to be the X and Y equals -1 over 5. Just leave it for now as it is. And then -2. -2 times 9 is -18. Then plus -1 times -8, which is +8. And then for the second value is -1 times 9, which is -9, plus 2 times -8, which is -16. and this is going to be minus 1 over 5 multiplied by minus 18 plus 8 is minus 10, and minus 9 minus 16 is minus 25. Okay, so now it's easy because this is going to be like minus 10 over minus 5 and minus 25 over minus 5. And this is minus over minus is a plus. 10 divided by 5 is 2. Basically, we just simplify. Minus divided by minus is a plus. 25 divided by 5 is 5. So the answers here, the solution, are 2 and 5. So that means x equals 2 and y equals 5. And that's it. Okay, as you can see, this is x, the first one, so that's the value for x, which is 2, and the value for y is 5. And this is the example from the slides, basically, so you can see it here. Where is it? It's here. Okay, so this is the x and y, and that's the y, and this is the x. Okay, so that's the solution for it. Okay, so that was an example for you to do, and therefore the summary for it here. Okay, square matrices have a determinant, and the determinant is A times D minus B times C. Okay, so that's the determinant. So that's A. It's same as the determinant, yeah? Or even you can write it as a modulus of A, but it can be negative. It doesn't have to be positive. Right, and the inverse of the matrix is 1 over AD minus BC, which means 1 over the determinant multiplied by the adjoint, A. Where adjoint A is when you swap these. So actually here they've been swapped already, yeah, because on the original was A and D. So now here we have them D and A. Okay. Oopsie. Right, and what is it? Let's go. Yeah, so so the adjoint is when you swap over these two diagonal and change the sign for these two. So that's why they are minus B and minus C here in this term. Okay. Inverse matrices can solve simultaneous equations, as I explained to you here on this example. Okay, I will give you another example. Okay, just let's move this a bit. Right, let's take another example. Let's say let me see the question. If we have 2x minus y equals 4 and 3x plus 2y equals 13. Okay, so we have these two equations, and we need to solve it to find the values of x and y. Okay, so solve these two equations using the matrices. Right, so first of all, what we need to do, write these two equations as one matrix, in one matrix form, right? Okay, so to write them as a matrix form, basically we need to look at the coefficients of the x, and the coefficients here are 2. The coefficients here are 2 and -1 and 3 and 2. Okay, so the matrix A is going to be the matrix here is going to be A, it's going to be 2, 3, -1 and 2, so that's A, and multiplied by the matrix X, which is X and Y, and this is going to be equal the matrix B, which is the matrix of the constant, 4 and 13, so that's B. Okay, and using the expression that we know we need to use for solving simultaneous equation, we need to use this expression, which is X equals A inverse B. Okay, so that's basically what we need to use to solve the equation. So therefore, from this expression, we need to find A inverse. So to find A inverse, we need to find the determinant and the adjoint A. So A inverse is 1 over det A multiplied by adjoint A. So determinant A equals, or we write it this way as well, same, but as I said, it could be negative, that's fine. So the determinant here is going to be 2 times 2 minus -1 times 3. Yeah, so 2 times 2 minus -1 times 3, which is 4. Then -1 times 3 is -3, minus times -3 is +3, and this is going to be 7. So the determinant of A equals 7, and therefore is not equal 0. Then this matrix is non-singular. That means we can find the inverse for it, so we are fine on the right way. And also we can check this 2 by 2 here. This matrix is 2 by 2, and this matrix is 2 by 1, and because these two together are the same, that means we can multiply, so that's fine. Okay, so I found the determinant. Now the adjoint of A, so adjoint A equals, as we said before, all we need to do is swap these over. Well, basically in this question these both are the same value anyway, so it doesn't matter, but anyway, the idea is to swap the places and change the sign for the other two. Change the sign for this and this. Okay, the pink one here. So the adjoint here is going to be still here 2 and 2, and the -1 is going to be +1, and the 3 will become -3 because we change the sign. And now I can use this, the adjoint and the determinant, to find the A inverse. So A inverse, therefore A inverse equals 1 over the determinant, which is 7, multiplied by 2, 1, minus 3, 2. Okay, I'm not gonna put the 1 over 7 inside the matrix because, you know, I will need to multiply this matrix here. I need to multiply this matrix now with B. Okay, so to find now, I will use the expression. I know like X equals A inverse B. Then that means I will use the A inverse, which is 1 over 7, 2, 1, minus a 3, 2, multiplied by B, which is 4 and 13. 4 and 13. Okay, so now we will multiply using this row with this column basically. Yeah, so this is B here. This is B and this is A inverse. So this going to be equal X equals 1 over 7 for now, leave it as it is. Then we'll multiply these two matrices. Again, to check it works, we have this 2 by 1 and this 2 by 2, and both have the same number in the middle, so it's okay to multiply. So 2 times 4 is 8. So 2 times 4 plus 1 times 13. Okay, and then for the second one, we will use this, again, we'll use this row with this column. So this is going to be minus 3 times 4 plus 2 times 13, sorry, 2 times 13. Okay, and this is going to be 1 over 7 multiplied by 2 times 4 is 8. So 8 plus 13 is 21. And minus 3 times 4 is minus 12 plus 2 times 13, which is 26. So that's 26. This is minus 12. So this is going to be 14. Okay. And now, therefore, the matrix X and Y, the matrix X, which has the values of X and Y, equals, now I can put the 1 over 7 inside the column matrix here. So this is going to be 21 over 7 and 14 over 7. When you simplify it, well, 21 over 7 is 3 and 14 over 7 is 2. And therefore, X value is 3 and Y equals 2. And that's it. I hope you understand it, and I hope that I made it clear for you. I know maybe I made it too long, but I was trying to explain the steps as much as I can, and I hope you understand it. Okay? Right. Shall I do another example now? Okay, I did this one. 2x, yeah. Let's see. Right, another example I will do for you. Oops. Okay, let's take another example. Let's say the two equations we have here is 3x plus 2y equals 7 and minus 6x plus 6y equals 6. Okay, so first of all, we need to write these two equations as one single matrix expression. So the coefficients here, we have the 3 and 2 and 6 and minus 6. So this is going to be the matrix A. So 3, 2, minus 6 and 6. And then multiplied by the matrix X, which has the variable X and Y. And this equals the column vector matrix, or the product matrix, 7 and 6. All right? To solve the simultaneous equation, we use the expressions X equals A inverse times B. And just to remind you, this is B, this is X, and this is A. So therefore, from this, we know that we need to find the A inverse, basically. Right, how to find A inverse? To find A inverse, we need to find the determinant of A and the adjoint of A. So to find A inverse, we need to find determinant of A, and also find the adjoint of A. Right, so A inverse, well, determinant A, let's say. Okay, determinant A equals 3 times 6 minus 2 times minus 6. All right, so this 3 times 6 is 18. Then minus 6 times 2 is minus 12. Minus minus is plus 12. So this is going to be 30. Okay. Just let me check if this is the same example. No, the example was over 5. Okay. And that was 7. Oh, okay. Right, so the determinant here is 30. Now, the adjoint of A is swap over the diagonals, the 3 and 6. So this is going to be 6 here, and the 3 will be here. And the 2 and minus 6, we change their signs, so the 2 becomes minus 2. The minus 6, it's going to be positive 6 plus 6. Okay, so this is the adjoint. Therefore, the A inverse will be therefore A inverse equals 1 over 30, yeah, multiplied by 6 minus 2 and 6, 3. Okay, I'll leave it in this form for now, because we'll multiply it by B to find X. Right, we already know that X equals A inverse B. Then X, which is XY, yeah, as small here, equals 1 over 30, and 6 minus 2, 6, 3, multiplied by B. Our B here is 7 and 6. Okay, so now we will multiply. All right, when we multiply, that means we'll multiply this row with this column vector, the B. So this is B here, and this is the A inverse altogether. So this equal, like, write it like XY equals 1 over 30 and then we multiply these together. So 6 times 7, which is 6 times 7, plus minus 2 times 6. And then the second row multiplied by the column, which is 6 times 7 plus 3 times 6. Okay, and this is like 42 here. Minus 2 times 6 is minus 12, so plus minus is minus 12. And 6 times 7 here is 42 plus 18. So this is going to be 1 over 30 multiplied by 42 minus 12 is 30. And 42 plus 18 is 60. So now this means xy matrix X equals 30 over 30 and 60 over 30, and that's 1 and 2. So that means x equals 1 and y equals 2. So the solution are x equals 1 and y equals 2. This is the values we want to find basically, and that's it. So now I solved 3 questions for you, and I hope that was clear enough to follow, and you will be able to do some more questions from the worksheet you have. Okay, thank you very much. Have a nice day and take care. Bye.